Welcome, everyone. Thanks for being here. I'm Matt Lange. I am the manager of our adversarial security testing team. I've been with Northwestern Mutual for a little over 10 years doing digital forensics, incident response, detection engineering early on in my career, and then transitioning to pen testing and red teaming and purple teaming, and I'm here with Gary Lobermier.
Yeah, I work for Matt under their adversarial security testing team, so been there about 3-ish years now. Been a sysadmin, network admin before that, so just doing red teaming, pen testing.
All right, are we secure? This is the fundamental question that ultimately our executives, our customers, our board wants to know, right? So all this other kind of nerd stuff that we're going to talk about here today is cute to them, and they'll pat us on the head and say good job, but really how we get it done is up to us. That we get it done is what they care about. So how do we answer this question, right? We can install next generation XDRs and SIMs and all sorts of fancy tools, and we should, and they're fantastic tools, but it doesn't, how do we know that those tools are functioning and doing the things that they claim to be doing is the answer we want to get to. So we think it's helpful to think about this question through a metaphor, right? And this is a quote that an old colleague of mine turned me on to from Dr. Eugene Spafford, which is, you're proposing to build a box with a light on top of it, and the light's supposed to go off when a unicorn walks into the room, or we need to bring the box into the room with a unicorn. How do you show that it works? How do you prove that that works? And so we extended that metaphor to say, let's say you did the impossible, right? You built this box with the light on top of it. It goes off when a unicorn walks in the room. How do you show that it still works today, tomorrow, next week, next month, next year? So when we ask, are we secure? This is the unicorn problem that we think about, that we believe that we need to address. So let's take it in the real world, right? Who are our unicorns? Well, it depends on who you are as an organization, right? It might be just chaotic actors on the internet. It might be, some 3-letter agency. It might be a financially motivated actor that you're concerned about. It might just be somebody who has it out for you, some hacktivist, right, who has it out for you or for your organization for something you do. But these are our unicorns that we need to be able to detect and be able to prove that we can identify with all these tools that we're purchasing and building. So that's our objective today, is to talk about how we emulate those attacker techniques so that we can emulate those attackers and prove that we can validate that our controls are functioning as expected. We want to be able to do that continuously, right? To be able to do that over and over again through automation so that we can constantly have assurance that we're doing this properly. And then we think that, in our experience over the past 6, 12 months to 18 months, what we've really come to decide is that we need to go beyond just techniques, the tactics techniques, and even sub-techniques of MITRE, and look even closer down into the small details of what procedures are, what we wish MITRE was tracking as procedures. And we'll talk about some of the tools we're using to do that. So, MITRE ATT&CK framework. If you're not familiar with it, you're not going to learn enough to know about it in my 30-second overview of it right now. So hopefully you're a little bit familiar with it. But if not, it's it's a knowledge base of adversary tactics and techniques based on real-world observations, right? Real reports from industry. The resulting framework provides a capability matrix that you can measure yourself, measure your organization against, to see how you're doing in detecting and defending against the real-world attackers or known threats. We don't restrict ourselves to this framework, right? We think of it as a starting place that we build on top of, and that'll become obvious when we talk about procedures later on. Really quick, tactics right across the top there is what an adversary wants to achieve when they're coming after your organization, and then the techniques and sub-techniques fill in that gap or fill in that matrix to say, here's how they're going to achieve those things, right? Down to the level of detail of each individual technique. And we build on those techniques with our threat injection and automation program that Gary's going to talk about.
All right, so threat injections is kind of a made-up term that we're hoping to coin, I think. Basically what we're doing is we're going into that MITRE ATT&CK framework and using that as one of the sources for intel on what we want to build. So what I mean by that is we might take a technique like, if you saw my talk earlier, DL sideloading, right? Or some sort of persistence technique, and then we're just gonna write a mini malware sample, right? So that mini malware sample is what we're calling a threat injection. It's just one little piece of work that we build to emulate the attack, right? So what that looks like, our process is basically to go through and select one of those techniques. Now, we might select it straight from MITRE. We might select it from our threat intel team saying, hey, this is something we care about. Or we might just think it's cool and we're going to go do it and execute on it. So what we do is we research that technique. We go deep into the weeds on it. How does it work? What kind of things what's it going to touch, right? Is it going to call APIs? Is it going to write to the registry? What do we actually have to do to emulate this MITRE technique? Once we research that, we actually want to build it. So if you're familiar with like MITRE's Caldera or the Atomic Red Team project, they go out and they build those little mini malware samples, right? They call them atomics, we call them threat injections, but we actually go out and build all of them ourselves. The reason we're doing that, we're going to script them later. So we don't just build them, we build them into a repeatable package, kind of like atomics, right? Where we can continually repeat this attack on a cadence. So having done that, we've got kind of a good idea of what this technique, the spirit of this technique, right? So it puts us in a good place to identify some common IOCs and document those IOCs and be able to hand that off to our blue team and say, hey, we built this attack, this is what it looks like, here's maybe some threads to pull on, right? So we can give them a starting point. So big picture, that whole workflow and what we're actually trying to do starts here. We select that threat injection, kind of a purple team exercise, right? What do we want to see? What do we want to emulate? Once we select it, we go wrap that up, build this mini malware sample, build this threat injection, and then invoke it on one of our machines. So entirely internal machine has all of our security tooling so we can see what telemetry we're going to get and what we don't. And the idea there is that when we invoke it, we're expecting to see whatever detection we made, right? So this is the crux of everything we're doing. Build the thing, identify what it does, go see that we are detecting it the way we expect to, and document, yes or no, we did it, we didn't do it. There's kind of an iterative loop here where if you don't detect it, we care enough to say like, okay, do we have it logged in our SIM at least, right? Can we use that logic, can we use that data to build some detection logic? And if we can, then kind of closes the loop for us and we can mark that one done. But then we go back through all of this and hey, it's not logged in Splunk. Do we at least have it logged somewhere centrally that we could get it into our SIM, build the detection logic, and rinse and repeat? If it's not central, is it at least local? Can we get it from Windows event logs, get that over? And then if it's not there, what else can we do? So that's our process overflow of overview of the workflow, right? How we want to do this. But there are a couple of things that really make this stand out, right? And the concept here being controls validation testing. If we have a control and it works today, the big thing is does it work tomorrow, right? Something changes, tech changes, updates come out, log sources change, something stops parsing correctly, right? So it may not work over time, which is the whole point of trying to automate all this. So if we look back at that workflow, the key is automating this cycle, right? We want to invoke it. We want to see that we got what we think it should do, and then we can close it. And if we can automate that portion of it, then we're routinely testing that we have what we think we have. So what that looks like from our systems starts with a couple of our internal images, right? We execute attacks on our AWS instances, our Windows, our Linux, our Mac instances, right? And the idea here is everything that we have some sort of detection built for, we want to test it, right? So all of our different platforms, we just keep adding them in. What it actually does is more or less a scheduled task, cron job type of thing that is executing a command and control beacon. So the idea here is actually send it over to a C2, and right now we're using Posh C2 to do this. I brought up MITRE's Caldera and Atomic Red Team, and there's a bunch of options, right? At the end of the day, we decided to build our own custom one. We built it off of Posh C2, not for any particular reason, but there are some good reasons to do it. We felt like we had more control over what we were doing if we used an actual C2. A lot of the times when we were going into MITRE's Caldera, it worked most of the time, but then we're like, hey, we want to do this, and you just can't because the tool doesn't offer it. So using an actual C2 framework meant it's completely extendable. Anything an adversary can do, we can also do, right? And that was kind of crucial for picking the framework that we wanted to build it in. So like I said, right now it's POSH-C2. It doesn't have to be. We've built it kind of decoupled so we can use whatever we want. But a couple of like key takeaways on that. If you're going to build it custom, POSH-C2 or other things like it, find out if you can use like an API to automate tasks inside of the command and control. POSH-C2 doesn't have that, but they do have a database that we can directly interact with, so we do that. Reliability is huge. We like this one because it's cross-platform. I can get Mac and Linux droppers. I can get Windows droppers. So gave us the ability to use one system across multiple platforms, and it's extendable. That's all we really need, is to be able to feed this system some sort of extendable script. So we execute a beacon on our internal machines over to POSH-C2, and C2 does what a C2 does. Beacon checks in and says, hey, what commands do you have for me to execute, right? And what we give it back is our threat injections, just every single attack technique that we have built out. Say, go run all of these, right? So it runs those, posts all that data back to our automation server, and then we can parse that and say, on this date, at this time, this attack was run on this host name from this IP address, right? And correlate all this information, and then take that information and post it out to Slack so we can see a real-time feed of like the attacks that are actively running in our environment, and then post that over to our SIM also so we can say, on this date, on this time, this attack happened, right? Theory's great. I'm going to try and show it to you. We have a demo video. Kind of looks like Swiss cheese because we're obfuscating some of the details that we maybe don't want to show. But before we actually go into the video, I'll give you kind of a primer of what is actually going to happen here. You'll see POSH-C2 in one corner of the window. There's another corner that has the client where I would actually hands-on keyboard execute things. Obviously, we don't do that in an automated system. So the other two windows are a payload dropper that we can use for, it's hard to show automation, right? So this is like a manual effort of that automation. And then finally, our automation client, which is going to handle those responses and send it over to Splunk. So there it goes. So just spinning up the client and the web server for the payload. That's POSH-C2 in the top left. Bottom left is the automation client. So automation client is basically just checking the database from POSH-C2 and saying, hey, what do you have for me, right? Now on a Windows VM, we can just execute some dropper, right? This is happening on a cron job normally, or a scheduled task for us. Manually execute the dropper. We'll get a beacon in the top left in that POSH-C2 window. And now the automation client is watching for that, saying, okay, do I have any new beacons, right? And if I do, it starts handling that. Starts saying, okay, got a new beacon. Go iterate through all of the custom threat injections that we've written and issue it as a command to that beacon. So you start getting hundreds of these loading on the left, and then on the right, you'll start seeing activity as these things are running. So it runs on the victim, all these different threats, posts back, hey, this just worked, that just worked, this didn't work, whatever it was, right? And then it's hard to see a lot of this, so rather than seeing it live in Splunk, here it is in Slack. This is the concept, right? T1234 just executed here. This is the technique. It's password policy discovery, and it just worked, right? So now we should have all the IOCs for that technique. And then it iterates through all these, network service scanning, password policy, domain trust discovery. So this runs for a couple hours every day on all of our machines, on our dedicated machines to this, because then we can trigger on a routine cadence every single day what detections are still working, right? So I stole this slide from our blue team because I absolutely love what this does. This kind of summarizes everything that we're doing and why it's really world-class, right? Like, this is really cool stuff. So the premise here is we have a detection. So we're just going to pretend like somebody's using proc dump to dump LSAS, right? Great detection to have. You create it, and then we see that it hasn't been triggered for 225 days. If it did get triggered, we'd want the red siren lights to go off. We want to page the IR team. We want tickets created, right? But it hasn't gone off in 225 days. And at some point you start going, man, I wish it would go off, right? I want to see it because I want to know it works, but I also don't want to see that ever, right? So we're waiting for something to happen, and that's where threat injections come in, where we can execute that attack. We can just run proc dump against LSAS, and we should see that last triggered date get updated. It should happen today. And if it does, do we want to create a ticket for IR? No, right? That's the beauty of it. We want to run these every day, hundreds of them. We don't want to give IR more tickets than they already get, right? Since we know it's a threat injection and we run them every day, we can say no ticket needs to be created. The results are logged so we can validate that this just worked the way it was supposed to and it was a planned attack, right? That gives us all sorts of metrics, right? Now we can go out and say, today, this worked. This worked exactly like we needed it to. Big green boxes all over the MITRE framework, right? But there's another really cool benefit to doing this. If we back that all up, we run the threat injection, but the last triggered date doesn't get updated, right? It still hasn't updated in 225 days. But we know we just ran the threat injection, right? Because we post that data back to our SIM. Now we can go back and say, hey, we know we should have gotten an alert, and we didn't get an alert, so fire an alert, right? Alerts on our alerts. That is the exact same thing we can do with, from metrics perspective, we can say, hey, this didn't work today. We expected it to. Today it's red. These are things we need to address. A little bit of that data, just the concept inside of Splunk. It looks a little bit like this, right? We do all these different attacks. We can measure on this date and time that it was successful. From the red team standpoint, this is also helpful for us because just like detections, your malware can stop working at some point too, right? So we go through the same exercise, like, I don't know why, but on this day and at this time, the credential dump from password stores using white chocolate macadamia nut, it failed, right? So now we have to go back and see why. Did that tool get deprecated? Is something not working like it used to? What happened there? We can also take all that, put it into dashboards, right? This is maybe a little bit more like a traditional KPI where you're just getting counts of what we're doing. We can overlay threat actors in the MITRE ATT&CK framework. It's a lot of really good data around what we're doing, what our coverage is, and how good we think we're doing, how good we want to do. Start measuring some more metrics around it. So as we started building this out, we kind of ran into new issues. And to walk us through that, we're going to start with one of the feeds that we get, like our threat intel research. They might come to us and let's say we look at the technique user execution malicious file. It's T1204, I think, yeah. We decided we're going to build something for SCR files. All right, let's build a malicious SCR file, execute it, run it in our threat injections. Cool, it worked. Post it as T1204.002, right? That's cool. And then our threat intel team, they're like, hey, this is a really cool system. We're starting to see some of this. Can we get in on this? Can you guys build a link file? We've been seeing a lot of link file activities lately. Why don't you put that into the system? And we look it up and we're like, yeah, that's T1204.002, so let's write that and post it as T1204.002. And then they say, yeah, that's cool, but we've been seeing like a lot of link files that execute with CMD. And we're like, yeah, that'd be cool, let's build that too. And then we'll post that, and it's T1204.002. And then they ask us to build it with RunDLL32, and we post that, and it's T1204.002. And now we get into this premise of like, okay, MITRE tracks TTPs, techniques, and then what, right? They don't track procedures. There's a million different ways for me to do this technique, this sub-technique. So how do we identify uniqueness across the execution of this technique and its detection? We got into this concept because I think we needed to define what procedures are. So a good example of what we're talking about is UAC bypasses. UAC bypasses is T1548.002. Okay, so we might have a detection. Anytime the MSC file shell open command registry write activity happens, that points to evil.exe, and then we see a process create for event viewer. Cool, that's our event viewer UAC bypass, and we wrote a detection for that, so T1548.002 is covered, right? Not really, right? Because did that cover any of the other UAC bypasses? If we do a FOD helper UAC bypass, CMSTP, the Winder environment variable, all of those are super unique, and they're not going to be caught by this detection, so we're not truly covered. So that brings us into some of our challenges, right? First challenge, we need to define what procedures are. We need to be able to track them in that level of detail, but since they don't really truly exist in MITRE, like, what are they? We have to define that. We also have to come up with a communication method that we can kind of standardize on and say, hey, if I talk about a procedure and I hand it off to threat intel or they hand it off to blue team and we all talk to it, we should use a common language between all this, between the procedures. We also want coordination between those teams, automation. We want to be able to see workflows happen in real time using that standard communication, and we want that so that we can automate these things, because there's potentially thousands of procedures in the already intense list of techniques and sub-techniques, right? So in our attempt to define procedures, we know we want to track in depth. And before we can do that, we have to define what procedures are. So we came up with a few things that have kind of stuck around. And one of them is the idea that technique IDs paired with a set of verbs, like a handful of actions that an adversary might take, that could constitute a procedure. So another way to think of that is a procedure might be like a technique that is even tool-specific, a tool-specific method for implementing a technique that demands a unique detection, right? So we want to get to that point where we have a one-to-one of this is the attack and this is the detection. So if we're trying to define that, what we care about is this concept of, like, what are the handful of actions an attacker might take? So we kind of came across this idea of, like, well, maybe it's like these objects and verbs, right? These file actions that you might create a file or you might write to the registry, and there's a handful of operations you might take. So we kind of tried to align it to the CRUD operations and just say, hey, I'm creating a file or I'm reading a file, whatever it is, right? And then we take that just a little bit deeper and we kind of want to say, like, attributes. Okay, so if I create a file, what do I know about that file? Do I know its name? Do I know the file type? The extension might be different than the file type. So can we track some of these details in a logical way? And I think what we came up with kind of starts to solve that problem of what are procedures, right? If we can define it in that way, then we kind of know what a procedure entails.
Okay, how we doing? We're good? So Gary did a nice job of defining, like, what our current process is and what the challenge we're facing here going forward is, right? We think we need this concept for procedures, and MITRE's not supplying it to us. So we need to be able to, we have that language now to use, but we need some way to document that language, right? We need to be able to transfer that around between teams so that all our different teams can emulate that, can go hunt for it, can go build detections for it. It needs to be documented consistently across all those teams. So we want it to be human readable, we want it to be machine readable, right? So naturally we went with YAML. So if we take that concept of procedures and that language that Gary started defining, this is small, and we start putting it into a YAML format, we can see that we have that. For example, if we take that UAC bypass example that he was giving us, right? The registry object, we can perform an operation on it, right? Our verb would be create. We want to create a registry object, and we want to then define the attributes of that registry object that we want to create. So we've got the key, the value, the data, and the type, right? We're going to create a specific key. We're going to make a default value. We're going to drop our malicious binary or path to our malicious binary in there. And now we've defined that specific part of the procedure. And then we just keep extending that concept. Now, okay, the next step of that UAC bypass is to create a process. So we've got our object, we've got our create verb, and we got our attributes. We're going to use CMD with a process command line of /c event viewer, and we're going to define where that process, where that executable lives. For CMD, right, not real useful, but for other binaries that might be malware, it could be useful for our detection team, for our hunt teams. So we wrote our registry key, we called event viewer, and when we called CMD /c event viewer, the natural thing, what's going to happen is that a child process is going to get created from cmd.exe, right? And we can track that through YAML, through its concept of keys and subkeys. So just the way we document this in YAML, we can see that event viewer is a child process of CMD, and it's got these attributes to it. So we continue on with our object verb attribute concept, but we're now tracking parent-child relationships between processes. Now, what does Event Viewer do? One of the first thing the thing that we care about is it goes and reads the registry key. So again, parent-child relationship here, key-subkey relationship. We can see that Event Viewer is the process that reads that registry key and does something with that data. And what it does is it's going to create another child process. So we've got grandparent, parent, child process relationship, all documented by that key-subkey concept built into YAML. And so here we have a nice little procedure defined out in YAML. It's got all the details that any of the teams might need to know. If we're going to build a threat injection, if we're going to emulate that adversary procedure, our team has what we need. If our detection teams need to be able to understand where they need to go look for evidence for IOCs of that UAC bypass happening, they've got what they need. Same with our hunt team. So we've got the procedure details. I hope that's not an eye chart for you guys, but what you see there is the procedure details from the last slide. But we want to be able to have some metadata to help string these things together, right? We don't just want these things sitting out there in isolation. We want to be able to translate these things into larger campaigns and track them across procedures so that we're not duplicating our work and that we can tie these things together. So we need some type of metadata. So if we take the MITRE technique, the MITRE attack framework details, right? We're just going to say, hey, this particular procedure lives under a technique. It's got a title, it's got an ID, and it's got a description, right? We just copy paste right from MITRE. Then we're going to add in our procedure metadata as well. So we're just going to copy that concept from MITRE and say, well, fine, we're going to give it a procedure title. We're going to give it a procedure ID, right? So we're just tacking on that .001, that dot notation that MITRE is already using, and saying we're just going to keep extending it out so that we can track these individually. And then we're going to give it a description just like MITRE does. We're also tracking a GUID that may or may not live on, but we just like sticks so much that we thought we'd do it. So we've got our procedure metadata, but the other thing we need for our threat intelligence program is to track that intel data. So we want to look at things like, we want to give this thing a score, our threat intel team does, right? Because do we care about this procedure? They might get a new piece of intel that comes in. They may get a DFI report. They might look through some open source intelligence and say, hey, this piece of data is really, really important to our organization because we care about this threat actor group. Or they might get a piece of information that says, now, that group's never going to attack us, so we don't care about them. So the first thing we want them to do is to score that, to classify how credible is that information source that it came from. Who's the person that's processing this documentation, right? Give it an author, give it some references so we can track back to that. We want to know who the threat actor is because that's going to determine whether or not that threat actor is relevant to our organization. And then we can track things like the targeted industries, and we can tag it with whatever we want. Here we've tagged it with a couple of pieces of malware, but we can tag it so that we can then track and collate these things over time. So it's getting a little complicated, right? It might not even be legible to you guys back there in the back, but there's a lot here. And so we want consistency, and we want a way to validate that this structure stays consistent across all of our documentation. So enter Yamale. Yamale is a tool written by 23andMe folks over there, and it's just a schema validator for YAML. So this allows us, to help make sure that we're performing these consistently, or building these documents rather consistently across all the different procedures that we use. So what that looks like is it defines the key and values that can be used in our YAML documents that we're creating. So you'll see, just like we had on the last screen, we've got our technique and procedure, title and description, and Yamale is going to say, hey, for this given key, the value should be a certain type, right? In this case, it's a string. Okay, easy enough. We can define whether or not that key is required. Can we build this YAML document without a MITRE attack technique title? We're going to say no, so we're going to make that required statement to be true. And then can the value that goes into that key placeholder, can that be none? Can that be empty? We're going to say no. We're not going to put in a technique title that doesn't have any value to it. So that's kind of the basic structure of this, that then just applies to different types and different areas of that YAML schema, or that Yamale schema. So as we look down into the other metadata, right, we can see that, hey, threat score is going to be an integer. Other concepts are the same. Makes sense. We want a number there. We can have lists of things, right? So if we saw back on our previous slide, we had targeted industries. It's a YAML list, so we can define a list of integers, right? Or rather, a list of strings in this case. And so this is how we're defining what should and shouldn't be in our schema documentation. We can have Booleans, right, true, false, and then we can then go define what does the actual procedure look like? What are the allowed objects that we're going to perform operations on in our YAML documents. So we can dictate all these things in this schema. The important part here down at the bottom is that there's this include statement. And this is just Yamale's way of abstracting the details to a different section of the schema. So if we pop over to where we see what we want to put into the process operation value, we're going to jump over to the process operation key and look at what's available there. And that should look familiar, right? It's our CRUD operations. And again, we have some include statements that let us know we're going to jump somewhere else. We've also got other operations, other objects that we think we can associate with those, the ones we saw before, file, registry. We got account, we got network operations, right? A process might make a network connection. A process might load a DLL. It's probably going to load a DLL, so we might be interested in that image load. So just some things we didn't talk about previously, or I didn't talk about previously. But again, with your include statements, then you can go down and jump to the create process or the read process details and see all your attributes. So we've defined the schema. We've got all of the different objects we have in there that we can define out in this schema to make sure that our documentation is consistent. And then you can run Yamale against it. And I don't know if you can see that, but basically you just point Yamale at the schema document that you put together, and you point it at a whole directory of YAML files, and it'll go through and say, hey, you derped the spelling of threat actor or threat score or whatever it was, right? So we're going to fail. It's going to tell you which file failed. It's going to tell you if you're missing any elements. It's going to tell you if you had, if you didn't put the correct value in or the correct type into an element. So it's a real nice way to just quickly validate that the schema or the YAML document that you built matches the schema that you've defined. And then you can run, if you fix those things, it'll say, give you a nice little thumbs up and say, yeah, you did it. So we got a valid YAML document. And then just extending that further, we're going to use GitLab CI, right, to automate all of this stuff. So we've got different stages in our that apply to our repo that says, hey, we're going to do some quality stuff. I skipped that. But we've got our linting stage too, right? The first thing we're actually doing is using YAML lint to make sure that we're actually putting properly formatted YAML in. But then we see our Yamale image actually builds off that YAML lint image, installs Yamale, and then runs it against our procedure schema. And then we can watch in our pipeline to make sure that every single time you check in a new document into that repository, that the pipeline runs successfully, and you know if you submitted a properly formatted YAML, properly formatted procedure. So we've got our defined procedure language, we've got our documentation method, right, that we can communicate. So now what we need to do is coordinate between all our different teams. So in an ideal scenario, we'd have our threat intelligence that lives out in the world. Our threat intel team would go gather that information. They'd prioritize that based on the threat actor. They'd document that into our nice properly formatted documentation, and they'd get that to all the teams that need that information, right? They're going to get that over to the red team's hands into detection engineering. They're going to get that over to the threat hunting team so that emulation, detections, and hunts can take place as quickly as possible. How we do that, and you can use whatever tools you use in your organization, but how we do that is, our threat intelligence teams has feeds to open source data. They use tools that they use to collate that data. However they get that information, they're going to turn that in, and one of our team members, Sam Gerke, built a Jira service desk automation workflow that has an intake form. And so they're going to pump that information into Jira service desk. That's going to create a kind of parent service ticket. So the Jira ticket that just manages all the work that all our teams do, then start getting created for the different teams. So our threat intelligence team is going to get a scoring ticket that says, hey, you need to go score this procedure to make sure, is this something we care about it or not? Once they close that ticket, the automation will then go create a YAML ticket that says, now you need to go build that YAML for that procedure, and they will prioritize that based on the scoring that they've already done, right? If it's an important if it's an important procedure, they'll jump on it sooner. Once they've built that YAML documentation, they will then close that ticket, and that automatically creates tickets for each of the other team's backlogs to go build emulations, to build detections, and to build hunts. So what we end up is once we're done with all this, we're never going to be done with it, but what we have now is a corpus of procedures that if threat intel finds a new procedure that they can go and search through that backlog or that corpus of procedure documents and see, do we see this already? Do we have this new piece of intelligence, right? So they can go grep through like, hey, what PowerShell process procedures do we have? And they can go see all the documents that include that type of procedure. Or they might be looking for a certain piece of malware, right? They might say, hey, do we want to see all the things that Bumblebee's done? Because we just got a new Bumblebee report in, and we want to go see if we already have detections and automations for that particular threat actor or that particular malware. And so we can take, if they find that they have that, they can go look at that pre-existing YAML documentation, and they don't need to redo all that work, right? They can just go find it and then add in Bumblebee as a tagged element on that particular YAML, and we've got it documented that yes, we're covered for this particular procedure that this piece of malware now has been seen using. So ultimately that gets us to our final goal, right, which is that mean time to emulation or to detection or to hunt, right? We want to get from threat intelligence hits the wild, Intel team knows about it, to we are building emulations, detections, and hunts as quickly as possible. And so we're limited because of the automation and because we have a consistent communication language to be able to manage that workflow and to communicate with. We're limited only by what our teams can process from their capacity, right? From their skills and their work capacity is the only thing limiting us to how fast we can do this, to do this work and to go from intelligence to successful detections or alerts or emulations. What we hope we might be able to do in the future is to automate some of this on the back end, right? So we've automated some of the front end, but can we take those procedures and actually use some of the, some of the AI intelligence out there that we might be able to automate some of that stuff in the future? So I think, Gary, you got a couple slides on talking about automation.
Yeah. So as far as what's next, full disclosure, like these are concepts, these are ideas. We've played around with some of these, and I think there's promise. What we want to do with some of this is two really big things come to mind. One is just like templating for future automation. So we get a piece of intel, and sometimes that intel is really specific, even though the technique itself might be a little bit generic, right? And so what do we actually care about in that technique? What matters, right? Does it matter if this batch file has this name? Does it matter if it's contacting this IP address? Or is it about using WebDAV over run DLL32? Or do we care about the DLL name and its export? And the answer is like, yeah, maybe, unless you don't, right? It kind of gets into this concept of like, we care when we do and not when we don't. And so we want to find a way to track that, but also be flexible enough to maybe just document the technique, but be able to fill in the other details as needed, right? So the idea is maybe we can get away with some sort of Jinja templating, right? And say, this is the underlying technique. New threat actor comes out and they're using that technique. These are the specifics, right? So that's the idea. There's some structure around it that we've looked at. I can't say we've implemented anything, but I think we've got some good ideas around what we could be able to do with it. The next thing we really, I think I'm pretty excited for is the idea to automatically produce threat injections. So if we get threat intel procedures that are variations of simple enough procedures, like we saw with the link file, right? Link file, 10 different ways that you might execute something using a link file. The idea is maybe we could feed those simple YAML procedures into ChatGPT and just get functions that do those things, right? And it's maybe not as abstract or far-fetched as you'd think, because if we give it a simple enough YAML, we do get a valid working PowerShell function, right? Okay, so it's PowerShell, we use that as a wrapper to produce the IOCs. That could work, right? And what that kind of means is we could take the results from ChatGPT, we could take that function, merge it with our existing template, right? The existing scripts that we're extending POSH-C2 with, and maybe just have that become a merge request that our team comes in and says, yeah, we got new threat intel, and here are the threat injections that were produced based off of it. Give them a quick skim and make sure that they actually work, right? And now what that gives you is like that mean time to threat emulation. As soon as threat intel pushes a YAML file, we might already have a threat injection, like seconds later, right? So I think there's a lot of promise there, and it's pretty exciting to think that that might be an option.
So that's really what we wanted to talk to you guys today about. So the takeaways for us are, if you're not already, validate your assumptions, right? If you think you have some detection functioning, if you think there's a tool that's protecting you in your environment, are you validating that that's actually true, right? We don't want to take, we like our vendors, but we don't take their word for what they're selling us. So, and then obviously automation, right? That we can't do this stuff at the scale we think we need to do it at. We have to build some type of automation into this so that we can get it done on the daily basis that we think we need. And then if you're not there yet, eventually we think you'll probably need procedures too, right? We came to this conclusion fairly early on. We started laughing, oh God, before sub-techniques even came out, when we were doing techniques, we said, boy, MITRE's gonna have sub-techniques soon. A year later, we were laughing and saying, oh, now we're gonna need sub-techniques, right? And here we are talking about sub-techniques or procedures. So we've used some, we have Splunk, we have some tools that are expensive, but you can do this stuff through open source, free tooling. It doesn't have to be super expensive. Gary talked about the C2 frameworks we're using. It's doable if you have some will to do it and some experience putting the programming behind it. So yeah, that's it. Happy to stick around for questions if anybody has any. Yeah.
So it seems like you guys put a lot of work into this. It's really awesome. So
That's Gary. I'm Matt. Yeah, that's. Right, yeah, fair enough. Yeah. So the question for everybody and for the recording was, how did we convince leadership basically to let us do this, right, as opposed to other valuable work that could be done? You know, I think we were lucky in that we didn't have too much pushback from them. Really, I think we just scared them a little bit and said, you know, you're spending all this money on these expensive tools. Do you actually know that they're working, right? Like, and we had experience where we would build a detection. We have an awesome detection engineering team. They would build the detection, and we would go check back on it. Not we necessarily, but the team would go back and check on it, and suddenly it would be broken, right? And we didn't know even how long it had been broken. We didn't know that it was broken. We didn't know that how long it had been broken. And so taking those stories to our leadership team, we were able to convince them that if what we care about, if we can't, you know, obviously we want to prevent things from happening in the first place, right? A goal, number one. But if we're not going to prevent them, or in concert with that, we want to be able to detect when something is prevented or missed. That is the core responsibility of the security team, right? Like, nothing my team does as a red team has much value if it isn't making our blue team better, right? If it isn't making our detection engineers better detection engineers, if it isn't giving our incident response teams the practice and the skills and the hands-on experience they need to get better at their job, then my team doesn't have much value in doing their red team activities. So I think that's kind of the story we told to our leadership to try to help them understand why we thought this work was valuable. So, yeah.
Yeah, it's a delicate balance, right? We've talked. Good call. Yeah, basically the question is, we're using POC2 to do this, right? We're putting droppers and running all these things all the time on our machines. So how are we, you know, are we burning evasion? Are we burning techniques? Are we burning the infrastructure? Because it's, you know, it's not bad at the end of the day, right? There's a balance there. Like, we've talked about, you know, how much do we bother obfuscating it versus how much do we just want to capture the IOCs, right? At the end of the day, the goal is to bring the telemetry to the blue team. So a lot of the infrastructure it's dedicated testing infrastructure. We'll do a dedicated tenant for our EDR. We do, you know, detect only mode so that we can execute it, know that it would have shut everything down, but didn't, so that we can keep executing it, keep getting the IOCs. So yeah, you do use, you mentioned, like, do we burn things? Do things get burned? Yeah, all the time, because as soon as they write a detection for it, well, now we know we can't use it in our next red team engagement because they have all of those detections already built. So we do burn some infrastructure, but it's mostly just ruining our own red team engagements in the effort of a purple team engagement.
I'm very comfortable with awkward silence, so. Any other questions? All right, well, thanks, everybody. We'll stick around for a while. Appreciate it.